Okay, these are the theories about the origin of Earth. We have planetesimal theory by Chamberlain Moulton, tidal hypothesis by Jean and Jeffrey, nebular hypothesis by Kane and Laplace, interstellar dust hypothesis by Schmidt, supernova theory by Hale, Big Bang theory given by many, the most prominent are Gamow, Delametre, and Hubble. So we're going to Earth's composition. Earth is very complex and diverse. It's not a single rock. It has a layered structure with inner inner layers being heavy and outer layers being lighter. This is best explained by nebular hypothesis of Laplace. According to it, Earth was a gaseous nebula. Later, it condensed, and through a process called gravity accretion, where denser materials are inward and lighter materials are outward. So D1 greater than D2 greater than D3. It resulted into planetary accretion. So it resulted in density stratification or differentiation, which is this thing. So basically the earth is made up of elements which make up the minerals, which make up the rocks, which make up the earth. So the most abundant elements are iron, oxygen, silicon, magnesium, aluminum, and nickel. And the minerals, the silicate minerals are most abundant. There are other minerals also. The important silicates are quartz, feldspar, orthoclase, plagioclase, muscovite, biotite, amphibole, pyroxene, and olivine. These are non-ferromagnesium silicates, which are also felsic. These are mafic or ferromagnesium silicates. Compare these both. These are lighter, these are darker, these are less dense, these are more dense. These are acidic, these are basic. They have iron and magnesium, they have calcium, potassium, and sodium. So the felsic minerals are seen up to 60 kilometers, mafic up to greater than 100 kilometers, mafic are more abundant. So mineral versus rocks, these are compounds, these are mixtures of minerals. They have a different composition. This doesn't have any such thing. These are the basic building blocks of the earth's surface. These are aggregates of minerals. Silicates are the most abundant minerals. Rocks, we have igneous, sedimentary, and metamorphic. Igneous rocks, we have granite, basalt, andesite, rhyolite, gabbro, and diorite. Sedimentary, we have sandstone, breccia, conglomerate, and shale. Metamorphic, we have slate, phyllite, schist, marble, and gneiss. So igneous rocks, according to silicon content, we have two types. We have two types, intrusive and extrusive, depending on where magma cools. If it's inside that, it's intrusive. Outside the surface, it's extrusive. So the most important rocks are based on silicon content. Extrusive are rhyolite, andesite, basalt, and comatite. Intrusive are granite, diorite, gabbro, and dunite. The most abundant ones are granite, andesite, basalt, diorite, and peridotite. Now coming to Earth's internal structure, Earth's interior is layered. This is explained by the nebular hypothesis. And as the depth increases, density also increases. Therefore, outer layers are much dense. They have felsic or non-ferromagnesium silicates. Outer layers are more dense. Inner layers are more dense, and they have mafic or ferromagnesium silicates. So earlier models, they were based on speculations which are given by Edward Swiss, Arthur Holmes, and Van der Graaf. CLC knife is a model given by the Edward Swiss. Modern contemporary theories, there are two types, which are chemical layering and mechanical differentiation. Chemical layering, it talks about composition of rock minerals and gives three layers: crust, mantle, and core. And they have oceanic crust and continental crust, outer, middle, inner mantle, outer and inner cores. According to mechanical differentiation, we have lithosphere, asthenosphere, mesosphere, and barosphere. These two together are called pyrosphere. Lithosphere is made up of crust and upper part of upper mantle. Now let's get to chemical layering of Earth's interior. There are two types of crust: oceanic crust and continental crust. We can see it here. Oceanic crust is thick. It is 60 kilometers thick. Some places it's 80 kilometers thick. Oceanic crust is thinner, 1 to 3 kilometers. This is lighter, this is darker, this is less dense, this is more dense. These are made up of non-ferromagnesium silicates or felsic. These are made up of ferromagnesium silicates or mafic. So obviously we have quartz, feldspar, orthoclase, plagioclase, and mica. Here amphibole is the most abundant mineral. Some pyroxene is there, no olivine is there. Olivine will be there in the mantle. So this is hard and brittle. This is relatively softer. These are acidic and intermediate. These are basic. The igneous rocks found here are granite, andesite, rhyolite, diorite, plus sedimentary rocks are there. And here only basalt and no sedimentary rocks are there. So this is the structure. Now coming to mantle, the density is 4 to 4.5, but the inner mantle will have 9 to 11 density. And obviously density increases with depth. The minerals found here are ferromagnesium silicates or ultramafic. Olivine is found in the upper mantle, and these are found in the deeper mantle. What are they? perovskite, spiral, spinel, and garnet. The rocks found here are peridotite and dunite. So the outer mantle is up to 350 to 400 kilometers, middle up to 700 to 900, inner mantle up to 2800 kilometers. Upper mantle, the most abundant mineral is olivine, which has a special property called semi molten. Because of this, it flows as a liquid. The core, the density is greater than liver, so it is very dense, it is very hot. So outer core is up to 4800 kilometers, inner up to 400 4800 to 6400 kilometers.